Hey everyone, welcome back to my daily coding series. Today is day 66. So I was looking through some of these problems and I clicked on this one basically randomly. So I'm just doing like medium array problems. This one is a sliding window problem. So let's take a look. So we're given a sorted integer array. We're given two integers k and x, and we want to return the k closest integers to x in the array. And we should do it in ascending order. Okay, so before I start, I want to lay out some goals. So I want to try to solve it, if possible, around 20 minutes would be ideal. It may take longer than that, or I may not solve it at all. I want to emphasize not over optimizing too quickly, and also to solve for the general case first instead of edge cases. So yeah, that being said, let's try to solve the problem. So also too, instead of using Microsoft Paint, I've been problem solving in here with the text editor. Because that's closer to an interview setting. Okay, so let's look. So given a sorted, one second, I'm just gonna move my keys. Okay, so we read this already. So my understanding is we're given x, and we have to return the k closest elements to x in the array. Yeah, so, and it should be sorted as well in ascending order, which is how we're given it. Is an integer a is closer to x than an integer b if the absolute value of difference is less than, or this is kind of, so this is what you'd expect, but this behavior here, so if a and b are the same distance from x and a is less than b. So for instance, if we have, let's say, so for the second bullet point here, if we have a equals -5 and b equals 5 and x equals 0, these are equidistant from 0. So the absolute value of these would be 0 equals 0, but we would say that a is actually closer because a is less than b. So in other words, if two elements have the same distance, we prioritize the element that is less than, less than. So obviously what comes to mind is, so let me just draw out an example here. So if we had x equals 3, so let's say k equals 3 and x also equals 3, so we need 3 elements that are as close as possible to 3. So my idea would be, so you'd have a window of size 3 first of all, because that's the 3 elements that you want, and you would slide the window to the right if this number is closer than this number. If it's equal, then you don't slide the window because of this clause here. So I would start my window here of size 3. I'd look at the rightmost element and see that, so that's good. So let's look at the next rightmost element, which is 3. So 3 is closer to 3 than 1. So we'll move over our window. And now we'll look at the next right element, and we see that 4 is equidistant from 2. So because they're the same distance, they're both 1 away from 3, we'll keep it as it is and return this window. So that's my guess at the algorithm. So I'm just going to assume that works and try another example here. So this is example number 1. I'll keep this for reference. So we have 1, 2, 3, 4, 5. k is equal to 4 and x equals 3. So we want 4 elements that are the closest to 3 in a sorted array. So I'd start with my window here. Actually, my window would be like this because it's size 4. So you always start off with, and let me just check an edge case. Actually, before, yeah, I guess I could do it. It'll be quick. So I want to see, can k be bigger than n if n is the length of the array? So no. So you can't have a window that is more than the array. So that's good. And also, so can x, so x can be anywhere. So x doesn't necessarily have to be in the array either. So like in this example, it could be -1. Okay, so that being said, there's some edge cases there. Yeah, and that was fine. They're pretty quick. Okay, so let's 1, 2, 3, 4. We start our window with 4. We look at 5 and 1 and see that they're equidistant from 3. So we just stop here, and that's our answer. If there was a 4 here, then we'd see that 4 is closer than 1, so we'd move up our window, and that would be our answer. So in this case, the answer should be 1, 2, 3, 4. Okay, correct. And now let's just look at example 2 before we start algorithmically coding it. So 1, 1, 2, 3, 4, 5, k equals 4, and x equals -1. So in this case, we'll start with a window of 4, start with a window of k. Now we'll check what's closer. 4? Is 4 closer to -1, or is 1 closer to -1? Because 1 is closer to -1, we will not move our window, and we will just return this. Okay, so the way I'm thinking, so let's try implementing it. I think this algorithm works. I'm going to assume it does, and if we run into edge cases later, we can do that, but for now I'm just going to work on the general case, like my goal. So we do need sort of the left side of the window and the right side of the window. So the left side of the window is going to be equal to k when we start. Right, so if I have 0, 1, 2, 3, 4, yeah, so k, so the window's rightmost index will not be included. Yeah, so we'll want 0 to 1, 2, 3, and then we won't include 4. Or maybe we should. Okay, so this is kind of an optimization thing. I'll keep it simple, so L and R are included in our window. Okay, so now we'll check. So the first condition, we want to keep moving to the right while array of R plus 1 is greater than array of L. And I'm going to just make it equal to, so it's not included. So the general case, when this is bigger than that, when R is bigger than L, we want to move our window up 1. So we'd say L plus equals 1 and R plus equals 1. And then we want to keep repeating this until this is no longer true. And if they're equal, we want to stop as well. So we will not include an equal sign here. And then we would want to return array from L to R as our answer. Our window size should be fixed because we're always returning k elements, and the distance between L and R will always be k. Now there is another edge case here. It's not necessarily an edge case, but what if, for instance, x was 900? So we'd always be moving our window, so we need to make sure that R is also less than the length of array, like so. So if it goes out of bounds, then that should work. Okay, so let me, I'll try running this and seeing if I'm missing anything. Okay, so I output 2, 3, 4, 5, but it should be 1, 2, 3, 4. So let's first think, is my algorithm incorrect in my head? And if it works how I think it should, then let's look at the code. So 1, 2, 3, 4, 5. So I'd start L at 0 and K is 4. So that's 0, 1, 2, 3, 4. So I'd do R right here. Then we'll check. So let me just write down the example. 1, 2, 3, 4, 5. K equals 4. X equals, what does X equal? Oh, okay. So it's not this. We're not checking if the one on the right is less than. We're checking if the difference is less than. So the absolute value of X minus this. So if the difference of R is greater than the distance of L. Well, actually, we want, okay, so if the distance is less than or equal, so if it's equal, we don't want to move the window. So what I'm thinking is if the distance from the right one is smaller than the distance from the left one, then that means we should move our window up. And if it's the same, then we should not move it because we prioritize the less one. Okay, so let's try to submit that. Okay, wrong answer. Okay, so it looks like this example will rework how I'm thinking about my algorithm here. So, okay, so we have 1, 1, 1, 10, 10, 10. L equals, sorry, K, what's K? 1? And X is 9. Okay, so how I think this should work in my head is we would have L here, and then K would be, so R would be right there. And then we would say the distance, so maybe we should store, yeah, so in this case, right, the distance is the same, so it will just exit and return 1, but we need to explore the rest of these items here. Because I guess my algorithm right now always assumes that that the midpoint like exists within. So how I was doing it before was this algorithm assumes, how much time? We're at 13 minutes. Okay, so this algorithm assumes that, what was it, K equals, use test case. I don't need that. Okay, so K equals 4, X equals 3. So the algorithm I have right now assumes that X is within your window. Yeah. It assumes that X is within your window because if X was, yeah, so if X was like 10, our window would be here, and then according to this code, it would say, well, the distance of this one is less than the distance of this one. So that's only if, so we should only, okay. So if I'm going to say R distance is less than L distance and R, so like array of R is greater than X. So that's an important distinction to make because if it's greater than X, that means anytime we move to the right, we're actually getting further away from it. But what if it's not greater than X? So in this case, what should the expected behavior be? Well, it probably should just move the window until So maybe we could keep moving the window until r is greater than x. So that would get us to here. So can we always just move the window until r is greater than x? Or I guess equal to x. I don't know, let me try it. So while r is less than length of array and array of r is less than x, let's move up the window by 1. So I'm thinking we'll move up the window by 1 until r equals or is greater than x. And then we should be able to apply our algorithm. So for instance, in this case, well, maybe not. Because if we have 1, 2, 3, 4, 5, we'd have L and R. And then we would, what's K? 3. So this would just get skipped. What if K was, like, what if this was 40 and 50? Let's say this was a 3 here. If this was 40 and 50, then our R would move here, even though that's not. So we would move our window here, even though that's not what we would want. So we only want so from the machine's perspective, we don't know what the next number is. So if this number is closer to x than this one, we should move it up by 1. And that's the algorithm that we currently have. So in the case of 40, 50, we would not move it up. But we also need to know ahead of time if there could be something bigger. So what if we just, can we just store it in memory? So we would just say, you know, we could just store, I guess, result as like an empty list. The only problem it might just be when they're equal. So if we have, yeah, so 1, 1, 1, 10, 10, 10 is a great example. What if this was 1, 2, 3? So if it's 1, 2, 3, right, then actually what's going to happen is it's going to keep moving to the right because this one will always be closer than this one when x equals 9. The only problem is when they're equal. Because it stops when they're equal. So could we say this maybe? And then only at the end, like backtrack or something like that. So while they're equal, we'll continue to go because there might be something further. And then once we get to where we need to go, so like if we had -5, 0, 0, 5, right, and k was, let's say, 3, and x is 0. So the correct answer should be here, but with the code that we have right now, it would be I don't know, let's say like this or something. K3. So this would be our window. So then it's going to check is 5, distance of 5 less than or equal to, and if it is equal to, it'll continue to move, which we don't necessarily want. And now it would stop. It would stop here. What if it was another -5? So I'm thinking what we could do is just store the distance of the rightmost of the window and then like keep moving our window back until the distance of L is greater than. So that way it would be like 2n. So we would do one pass to, go all the way until where it doesn't make sense anymore, like until the distance of the array of R is greater than the distance of array of L. But just to avoid ties, we would like move back while it's equal. Okay. So what I'm going to do, I'm going to keep that one example, but okay. So I'm going to do this, and then I'm going to expect that it should fail under some circumstances. Okay, this is another place where it should fail, I believe. So 1, 2, 3, 4, 5. So let's look at this one. We're at 22 minutes. 1, 2, 3, 4, 5. K equals 4 and X equals 3. Okay. Yeah, so I think all we have to do now is just shift the window until the distance isn't so while we could say if R equals length of array, just turn that. So if we made it all the way to the end, well, maybe not necessarily. That's kind of another weird edge case. So I'm thinking we can, while the distance, so while now that these are equal, we can move backwards. Yeah, let me try that. So this, I'm expecting maybe like an out of range error here. Yeah, so this is out of range. So maybe I could just redo the logic. So if this is true, then we'll move it back. First we have to say if R is greater than or equal to the length of array, then do it. Yeah. So if it's greater than the array, okay. So if it's greater than the array, do we just always want to move it back? No. Okay, so I'm getting a bit confused, so let me look at an example. So we have L, R. Now we see that we see 4 is closer than 1, so we move them both up. And now we see that 5 is not closer. So let me print L and R right here. So it should be 1 and... Oh, well, I guess actually R would start here. And then we'd see that they're equidistant, so we'd move both of them up by 1. And now this is out of bounds. So yeah, it's tricky with the... Because we want it to stop, but... Maybe we could say if it's the same... Like, okay, k equals 1, x equals 9. So I think there might be a better way. So I'm just going to take a step back and brainstorm this for a second. So we have L and R. We only want it to stop should I say and array of R is greater than X? So here the distance is not true. Maybe we want to keep going if it's less than. Well, we always want to stop if it's out of bounds no matter what. And then I guess we would group these together. So we want to keep going if the distance of the distance of R is less than the distance of L, we should go. If they're equal, though, we also want to make sure. So if this is not true, so what's another example where that could be not true? So if we had x is -1, right, then this would not be true. Well, like in the second example, right, if we 1, 1, 2, 3, 4, 5, k equals 4, x equals -1. So in this case, 0, 1, 2, 3, 4. So in this case, this evaluates to false, and this also evaluates to false, so we should correctly stop. In this case, this evaluates to false because they're equal, but this evaluates to true, so we should keep going. Bool has no length. Why did I put length? Oh, I just put my parenthesis in the wrong spot. Okay, are my parentheses lined up? No. So parenthesis, I don't. All right, let's try that. Okay, let's see, submitting it, if we get any errors. Okay, we got it. So, kind of took me a bit. So we're at 30 minutes, that's not bad. So what happened? So I had a good plan, and then this test case threw me off. So I think I had the right idea almost instantly. I remember saying this, but then I kind of went off and overcomplicated things. I realized I was overcomplicating things, so then I went back. So I think when you are faced with an edge case like this, or something, not necessarily even an edge case, but a case that doesn't align with your algorithm, I should think of, so what did I do that made me successful there? So I thought of in which situations my algorithm worked and this one didn't. And then just like all I had to do was add this or statement. So I guess that's the key, is like think about when the algorithm works and when it doesn't. It should be really fast actually once I take all this stuff out. It's like super simple. It's just this logic here. Yeah, uses no memory. Yeah, so just to recap my solution, the idea is, so we have a window of size k, because we know that the import array is already sorted, and then we only want to continue moving it right if the distance, so if the right element is closer to x than the left element, we want to of course include the right element instead of the left. If they're equal, we don't want to move up just because of this clause here. So if we had like -5, 0, 5 with, we wanted to get the two closest elements to 0. So we would not, so we'd have L and R. So our window would be from L to and R not inclusive. So it would be here. And then we'd compare 5 and -5. The distance to 0 is both 5. So we would not want to move it up unless, so that was my initial algorithm, which worked, unless so we don't want to move it up unless that the rightmost element is still less than k, then we would want to move it up. So in this case, we had a window of size 1, so r is not included, and so k was 1 and x was 9. So in this case, they are equal, so we shouldn't move it unless, so now this part, the unless applies, that array of r is less than x. So 1 is less than x, which means that the closest part could still be over here. So then we should move it. Or I guess it must be over there. Yeah. Because if it was, what if it was like 20? So in this case, r is, so if we have 1, 1, 20, r is, so they're the same, so this evaluates to false. Array of r is less than k, so this, they'll both move up. And now you're just fine, because now this will be false also, and this will be false, and this will be false. So basically, this just lets us explore where the answer could be if it's to the right, but it still gets caught. Like even if exploring to the right isn't it, it still gets caught because of, we're still checking the distances. So yeah, that's it basically. So you just have to make sure that these two things are true, either one of them actually, and then just a simple out of bounds check, and you just move your window. So yeah, the code looks really simple. It's only like, how many lines is that? 5. But yeah, still takes a lot of thinking. So I solved it in about 30 minutes. So that's not bad. So yeah, today was day 65. Thank you guys for watching. Or wait, what's today? Day 66. I think today was day 66. But I'll see you guys tomorrow for day 67, I think. But yeah, thank you.